Practice exam is Monday next week, and Tuesday we go over it. Wednesday, Thursday is our actual exam next week, right? So Wednesday, Thursday next week is our actual exam. So exam 2 is Wednesday, Thursday, October, whatever that is, 4th and 5th? 4th and 5th, all right. So how do we do, to finish this up, I want to get into that next section because it's the biggest one we've had, 5-4, today. So 2 to the minus x equals 4. How do we solve that thing? What value of x could you plug in there that makes that true? Could you solve it by observation, so to speak? Could you just kind of look at it and say what x number you could put in there? What number could you put in the x spot that would make that thing a true statement? Can you tell? Anybody have an idea? -2. So if I made x -2, would that work?
Negative.
So what would negative be? Positive. 2 to the positive 2? Is that 4? Yeah? That's right. X equals -2 is the answer. We just solved by observation, they call it. We just kind of looked at it. But let me give you a method, though. So how would you, what's the actual method? So solving x in the power zone. X in the power zone is called exponential. That's what this whole section's about, huh? Exponential. Yeah, x in the power zone is an exponential function. How do you solve exponential functions? X is in the power zone. What do? Step 1, you make the bases the same. Step 2, then you set the powers equal. What do I mean? So I mean, we solved this one by just kind of looking at it, but let me show you the steps that normally are necessary, especially when they get harder. What do? Well, you got to make the two bases be the same. So how can I rewrite the 4 2 squared, huh? Does that make sense? So now I've made the two bases the same, haven't I? That's step 1. So as soon as you make the two bases the same, you know that the two powers must be equal. Get rid of this. Why? Well, because if I said, hey, 2 to something is equaling 2 to something else, those somethings must be the same power, right? They must be equal powers, or 2 to one of them wouldn't equal 2 to the other. If they were different, powers, how would 2 to one of them equal 2 to the other? They wouldn't if they were different powers. So those powers have to be the same, don't they? They have to be equal. So as soon as you've made the bases the same, you know the powers can just be set equal. You can cut out the bases in a sense, that's what we're doing, and just go right to the powers, because logically the powers have to be the same, or 2 to one of them wouldn't equal 2 to the other, right? So then once you have that, you go, oh, okay, now I can just solve the powers, and that's not a hard equation to solve. Just divide by -1, and sure enough, there's the answer, which we'd already known was the answer. So there's the method. Make the bases the same, set the powers equal. That's how we'll do it even when they're too hard to solve by just looking at it. Good? That's the kind of a weird one. Or just using a calculator. So, 4 thirds to the x is 64/27. So what I'm suggesting on this one is just look at that 4 and think to yourself, what power, what does that x have to be? What power? How many 4s multiply together to be 64? And it's actually 3 of them. You try to calculate 4 times 4 times 4. So does that work for the 3 as well? Is 3 times 3 times 3 27? Yeah. So what's that power need to be? 3. We're done. That's all you really need to do on that one. Kind of calculator observation. I'm not going to do any big fancy method or anything on that one. All right, let's go to, that one's not. So 18, we got 5 to the 2x plus 1 is 25. All right, so say you're taking the exam next week, a lot of the battle on a math test is just realizing what to do when, huh? Like, okay, what categorizing. Looking at it and go, okay, what's this one? How do you do this one? Well, this is x in power. So you want to have in your 3x5 card x in power, right? You see up x in the power zone. You go, oh yeah, what do you do? What's step number 1 when you have x in power? Base is the same. Make the bases the same. bases. So make the bases the same. Step 2, powers equal. Okay, so can you do that real quick? Try to make those two bases the same, and as soon as you do, then you can just cut them out and set the powers equal. And solve from there. So do that, compare to those around you, see if you get the same answer. So 25 is 5 squared. So we made the bases the same. Now you can cut them out and just set the powers equal. Why? Because if 5 to something is 5 to something, those powers have to be the same. Or 5 to one of them wouldn't equal 5 to the other if they were different, right? So now the powers equal, solve this, subtract 1 from both sides, divide by 2, it's a half. That good? Is method making sense? Base is the same, cut them out, powers are equal, solve them. Is that really true? Is the answer really a half? It is. You can go back here and see it. If you put in a half for x, what would be 2 times a half? 1 plus 1? 2. 5 to the 2? Yeah, 25. It's true, huh? Half's really the answer. That's right. All right. So 4 to the x squared, 64 to the x. Okay, so you know the steps. Step 1, base is the same. Should give that one a try. Make those two bases the same. As soon as you do, cut them out, set the powers equal. So use your calculator. 4 times 4 times 4 is 64, right? 4 to the third. So then we go, okay, this is 4 to the third. So base is the same. Then cut them out. Step 2, powers equal. So x squared is equal to 3x. Good to there so far? Now, do you know, you remember, I'm sure you've done before, do you remember how to solve an x squared equation? Well, no, not when it has an x squared and a rate. If it's just x squared and a number, square root would be right. If it's just x squared and number, yeah, just root both sides, you're good. But see how it wouldn't work if you have an x? Let me show you. What if I rooted it? Here you go, there it is, x. Well, yeah, but what does it equal? Root of 3x? X isn't alone. See, that wouldn't work? So that's only if you have just x squared in numbers. But if you have a couple x's, what do you got to do? So let me give you the x squared solving plan. Just remind you of it real quick. Step 1's about, you got to get a 0 first. Get a 0 and then factor. You know, like with parentheses. And then step 3, each one equals 0. So yeah, so first I've jumped the 3x to the other side, which gets you a 0. So step 1 is to get a 0. So get a 0 on step 1. Step 2 is factor. How do you factor x squared minus 3x? Take out the x. Like that. Right? Because if you distributed that, it would go back, huh? Good to there. And now, each one equals or y, because these two things are multiplying to equal 0. If you times two things to equal 0, either one could be 0 to make them multiply and be 0, huh? So that means the x alone could be 0. That's one answer. Or the x minus 3 could be 0, so jump the 3 over. X could be 3. So the answers are 0 and 3. They want you to separate them with a comma. Either order, you put 3, 0, 0, 3. No parentheses. It's not graphing or anything. It's just two separate answers. 0, 3. Good there? Does that make sense? No questions? All right. Okay, so 64 to the 3x is 16 to the x plus 2. So try that one. You know the steps. Base is the same. So make those two bases the same. Set the powers equal. You can't, the 64, it's a little trickier this time, huh? 16 times 16 is not 64. It's too big already, huh? So you really can't make the bigger one out of the smaller one. So what do? Lower them both. Make them both out of a smaller number. Because you got to make them the same, right? So you got to make them both out of the same material, so to speak. Make them both out of 4. So use your calculator. Find out how many 4s to be 16 and how many 4s to be 64. There's the answer to that. Right? So make them both out of 4s. Because you got to make the bases the same one way or the other. You can make them both out of 2s also. But that would be more work. That'd be a lot of 2s. Just make them both out of 4s. So somehow you have to make the bases the same. Both made out of the same number. So this is 4 squared. This one's 4 cubed. Good? Okay, but then what about the 3x? And what about the x plus 2? I put parentheses because the 64, the whole thing, the 4 to the third, is raised to the 3x power. And the 16, the 4 squared, the whole thing is raised to the x plus 2 power. Good so far. Now, what do you do from there? Do you remember the power rules? Do you remember, like, if you have, put it over here. If you have, like, 2 to the third times 2 to the fourth, that's 2 to the third. They add in that situation. I think that one you remember, right? They both have their own base of 2, powers add. But what if you have, like, 2 to the third parentheses to the fourth? Do you remember that in that situation they actually multiply 2 to the 12th? Do you remember that? Because that's only a single base of 2, not 2 different 2's. And power outside parentheses multiply powers inside parentheses. Remember that rule? So that's what we have going on here. 3x multiplies, because there's a single 4 as the base, single base. And the 2 powers, powers outside multiply powers inside. So that's 4 to the 9x. Same thing here. This 2 is going to multiply these guys. So that'll be 2x plus 4. Good to there? Remember those rules? Kind of, sort of. Now, cut them out. Powers equal. Solve from there. Just subtract 2x. Boom. 7x is 4. Divide by 7. 4 sevenths. We happy? We good? Questions on that? And make the bases the same, and then make the powers equal. So 4x squared minus 3 is 16 to the x. Try that one. So make the two bases the same, cut them out, so the powers equal. Sixteen's 4 squared. Like that, we get to there. Bases are the same, cut them out. So step 1, bases equal. Step 2, powers equal. Powers are now equal. Can you solve that? So go ahead and solve that now. It's an x squared equation. You know the game plan, get a 0 and factor. And then factor. Right? Am I going too quick? Does that make sense? So I jumped that 2x over, became a negative 2x, and then we factor. Remember factoring? What multiplies to be 3 adds to be negative 2. What times what is 3? 1 times 3 or 3 times 1, whatever. How do you do the signs, though? The sign in the middle, right? That 2x jumped over, became a negative 2x. Sign in the middle, negative. Sign in the middle goes on the bigger number. Sign in the middle goes on the bigger number. So plus 1 minus 3 makes minus 2 in the middle, huh? But then when you do the final equals, it switches signs, don't they? Right? Because you set each one equal, like you set x plus 1 equal to 0 and x minus 3. And so when you jump it to the other side, it switches signs. So minus 1 plus 3. So those are our two answers, minus 1 and plus 3. There we go. You can check them out. You can plug them in. They're true. They make it true. Questions? Are we happy about that? Twinkle, seems like. So 9 to the x times 3 to the x squared is 81 squared. All right. So make those all out of 3s, right? All out of 3s. And then put them together. So then you're going to have to, so that 9 is 3 squared. The 81 is 3 to the 4th, right? Use your calculator on that. Is that good? Is that coming out good for you? So, 3, 4, 4 threes multiplied together. It's 81. We good there, and then the 9 is 3 squared. Okay. Now, can you put those, you got to make it a single 3 and a single 3, don't you? You got to take these two 3s left, you got to put them together somehow. You got to combine those two. So how do you combine those two? What happens with these guys? Same bases multiplied, powers add, huh? It's going to be x squared plus 2x, or 2x plus x squared. The order doesn't matter. And this is 3 to the 8. These guys multiply. Everybody see the difference? You okay with all those power rules? This is the trick. You got to be clear on all those power rules. Right, everybody see that? See how this is two different 3s? Powers add. This is a single 3. Two bases on a single 3. They multiply. Or you could say powers outside parentheses multiply powers inside parentheses. Whichever way works for you. Those guys add because they each have their own 3. All right, so we get to there and now cut it out. So there's step 1, bases. Make the bases the same, which we did. Step 2. Powers equal. So now you say, okay, x squared plus 2x is 8. There it is. Solve it from there. You know how to solve it, right? So we just jump this 8 to the other side. We get x squared plus 2x minus 8 equals 0. Solve that. And that's what? 2 and 4. 4 times 2. Sign in the middle goes on the bigger. Plus 4 minus 2. Good there. And then, I'll just jump to the opposite sign. There we go. Minus 4 plus 2. Right. We good? Questions I can answer? Yeah.
Why wouldn't we multiply them?
No Emmy, right? Yeah. Why would we do what's that?
Why wouldn't we multiply them first?
Oh, yeah. Good question. Really good question. Yeah, like 9 times 3, 27. Yeah. Good question. I didn't think about that. Yeah. It's because they, well, they just have, because they have powers on them. Yeah, and different powers. Yeah, that's really it. Yeah, they just have different powers, so, yeah, can't do that. Yeah. Good question. Yeah, if they both, if it was just a regular 9 and 3, we totally would. Okay. Yeah, good. Other questions? So we've got e to the x, and we've got e to the 5x plus 24. Yeah, remember, same bases. Who cares what the base is? Just bye-bye base, huh? Right? E's just a special number. We don't care. So bases are already the same, right? Step 1, base is the same. They already gave us same bases, so great. They're out of there. Step 2, powers equal. So you set x, you set x equal to 5x plus 24. Set the powers equal. Is that good? And then you just solve for x. And so subtract 5x from both sides. Would that be minus 4x is 24. Last step, divide by minus 4, so x is minus 6. We good? Questions on that one? So e's nothing special. So we've got e to the x squared equals e to the 9x, 1 over e to the 20. Okay. As soon as you see that fraction, guys and gals, what do you think? What do we always do in these exponential power situations when we have fractions? What do powers have to do with fractions?
Negative.
Negative. Good job. Good answer. Negative powers flip things, don't they? So as soon as you see that 1 over e to the 20, you should go, oh, I know what they're doing. That's just e to the minus 20. Exactly. Negative, right? Negative powers flip, don't they? Yeah, so do that first. Excellent. That's the first step. Take it from there. Now you got to put those together, right? You got to make it 1e on this side, and it already is 1e on the other side. So you got to take these guys and put them together somehow, right? Make it a single e, and then cut out the bases. So the power's equal. Give you a second, see if you can finish that up. So same bases multiplied, powers, add, plus negative, or just minus 20. Same. I would just make it minus 20. Plus a negative 20 is just minus 20. Right? Same bases. You just do that. And now, boom, bye-bye bases. Right? Step 1, same bases. Did it. Step 2, powers equal. So now the powers are equal. Now we solve an x squared equation. How do we solve x squared equation? Get a 0. Right? So jump this over, jump this over. What's that? Minus 9x plus 20. Let me let you give you just a second. Finish that up. Make sure you can do that okay. We good? So then factor that. What times what multiplies to be 20? What times what's 20 and can somehow add to be minus 9 in the middle?
4 and 5.
Yeah, 4 and 5, huh? Both negative, huh? Because two negatives multiply to be plus 20 and they add to be negative 9, huh? And then you said each one equal to 0. It's actually going to be plus 4 plus 5 when you jump them to the edge. Okay, if I just skip right to that. Plus 4 plus 5. Those are the final two answers. Good? Questions on that one? We're happy? I'm aiming for your happiness. I know you'll be happy when you can get them all done and right and get on with your life, get through math class here. That's my goal too. Questions? All good? Yeah, it's kind of a weird question at first. They say, okay, 8 to the x is 7. 8 to the x is 7. And they're saying, hey, what is 8 to the minus 2x? That's kind of weird. I mean, normally they ask us for x, right? They say, solve for x. They're actually saying, no, I want to know what 8 to the minus 2x is. It's a weird question. Well, but all you got to do is just bring the 8 to the minus 2x down below the start. And then just ask yourself, say, what power could I put out here to make this look like that? Well, negative 2. Everybody good with that so far? Right? Because, powers outside parentheses, multiply powers inside parentheses. So negative 2 times x, negative 2x. Okay, but that means, I'm taking the original true statement they gave me. 8 to the x equals 7, right? They gave me that. They told me that right here. If 8 to the x equals 7. If that's true, that is true. They're saying that's true. You can work with that. You can use that. So I take that and I say, okay, whatever you do to one side, if something's true and you do the same thing to both sides, it'll still be true afterwards, right? Two things are equal. You treat them the same, they'll be equal afterwards. So if I raise both sides to the negative 2, they were equal before, they'll still be equal. The left side will become what they're asking me for. So then, whatever the right side is, that's their answer. So what is 7 to the minus 2? What's the negative power do? Flips it, 1 over, and then the power becomes positive after the flip. You guys with me on that? Everybody real clear on the negative power? They're going to just push that, in the next section even harder, backwards. Logs are exponentials backwards. You really got to be clear on that. Negative powers are flips. So the negative power flips it, and then the power becomes positive, and then you work it out, 7 squared, 49, done. So does that make sense? We took what they gave me to start with, made it into what they're asking me for by negative 2 power, did it to both sides, got the answer. Okay. Go to another one. Change question. Oops. Okay, so they're saying, they're giving me a starting point. 9 to the minus x is 14. And they're saying, hey, what's 9 to the 2x then? So basically, do whatever it takes to transform the left side into what they're asking me for. And then do the same thing to the right side. You gotta do the same thing to both sides. So raise both sides. Well, what power? Negative 2, huh? Because negative times negative would be positive 2x. Like good. We do one side, do the other. Right? If they're equal before, treat them the same. They'll be equal after. So what does that mean? 1 over 14 to the positive 2. Is that like 196? There it is. Not good? All is well? No questions? So we just made the left side how they want it to look, did the same thing on the right. All right, so there's number 28. They're giving me a picture. Now, we did some of these yesterday. This one's going to be a little harder because there's no multiple choice help. It's just type in the right answer rather than grab the right multiple choice option. So you just have to type it in. So it's a good little review on because we did it yesterday as well. It's good to remind you. So go ahead, see if you can come up. Remember how exponential functions work. It's y equals a times b to the x plus c. Remember that whole thing? This graph leads to some exponential equation. Remember that yesterday? You weren't able to think about anything else all day, right? Just exponential functions, how their graphs look. Maybe not. Maybe I'm thinking too much of my class in your life. All right, so remember that? Kind of, sort of? What is the C? Horizontal asymptote. Where's the flat horizontal asymptote? Now, they're not showing the dotted line, but can you tell where the graph's kind of leveling off? It's at 0, huh? It's right there. It's y equals 0. They're not showing it. They're not putting a dotted line, but we can see, right? The horizontal is where you come for a landing, right? So, yeah, so that's just 0, so that's out of there. That's why they said it's this form. They're meaning there's nothing off to the right. So all right, so it's a times b to the x. Can you tell what the a is? What's the a? Yeah, it's the jump. It's the jump, right? From the horizontal to the starting point. Yeah, that's hard to tell. Let me get back to here. They're telling me right here. Over 0 down. It's so small. I should make that graph bigger. Anyway, they're telling me it's 1 unit away. Can you guys, let me draw it a little better. Let me draw it bigger is what I mean. So they're basically saying the graph goes like this. It's just so small they're not showing it. They're saying it's like that. Does that make sense? So even though it's really tight up in there, you can hardly see it. That's what they're saying. It's over 0. This dot is over 0 down. So it's 1 unit away from the horizontal. 1 unit down. So A is -1, isn't it? Remember, A is the jump amount. It's how far. This from here to here. This is A, which is -1. It's how far from the horizontal dotted line to the center dot. So -1, remember that from yesterday? Okay, now I'm down to the B. What's the B? Well, I'll do it formally, but can you just look at 8 and 64 and tell me what do you think B is? It's 8, right? 8 to the first is 8. 8 squared is 64. That's where they're getting those numbers. But let's just be formal about it. Formally, you could just plug in a point, and you'll exactly find it. It is 8. It will be 8. But let me formally show you. What it means is if you plug in x is 1, y is negative 8, x is 1, y is negative 8, you can solve for b. Negative 8 equals negative 1 times b to the 1. Right? So, divide by the negative 1. That's 8 is b to the 1, so b is 8, as we said. So there it is. It's y equals negative 1 times b, 8 to the x. There's the formula of that exponential thing. And you knew there was a negative in the front, huh? That's what makes them jump vertically, because normally they go up, don't they? This one's been vertically flipped down. That's the negative y flip in the front. We knew that. So there we go. Remember all that kind of stuff from yesterday's graphing? All right, so let's try it. Finally, it updated. Good. All right, updated it. Moved. All right, yeah, let's try this one. This will be good. 30 is harder than the last one, so this will cover both. So let's do this one. So first off, h of negative 2. H of negative 2. So here's a function. It's an exponential. Why do I call it exponential? Let me make sure that's clear in your mind. What is the definition? And I'm not normally into definitions and all that, but this one will be helpful, especially if you're going to calculus. What does it mean to be an exponential function? What does that mean? Would this be right? An exponential function is a function with exponents, powers. That's not the whole story. And it's important you know that difference. Why? Because this is not exponential, although it's got exponents. Do you know that difference? That would be a big deal in calculus. Because the derivative, what's wrong? Why is that not exponential? And what is exponential? Yeah, not just that it has powers, but that it's got x up there in the power zone, right? X has climbed its way into power, right? Powerful position, right? I'm listening to the biography of Winston Churchill as I drive around. I heard today on the way to work the meeting between, it was there about a year from the end of World War II, and in Tehran, it was a famous meeting. Churchill met with the President of the United States at that time, who was FDR, Franklin Delano Roosevelt, and the other big, powerful, horrible man, Joseph Stalin, right? The three met to make their plan on wiping out Germany, and Germany was banking on the fact that America or England would realize that Russia was worse than Germany, and which is true, but they never realized that. Anyway, but there were those three powerful people sat in a room and planned for what they said they had 20 million armies or soldiers they all controlled throughout the world. Anyway, power. When the wrong person gets into power, that's a rough thing. So X in the power. I'm doing a little. I'm a wannabe history teacher. Thanks for indulging me for 30 seconds of history. I'm a wannabe history teacher. All right. X climbs into power, so I hope you'll remember the math too. So that's exponent. It's a big deal in calculus that you really know, because the rules for derivatives for functions like this is just a polynomial. Functions like that, the derivative is totally different in calculus from things like this. That would be exponential. Everybody see the difference? So it's not just that there is power, but it's who got into power, right? Terrible that Stalin got into power. Terrible that X, well, I don't know if it's terrible, but anyway, it's a powerful thing when X climbs into power. Okay, so we look at this function and we say X is in power. That's exponential. So what do they want me to do with this function? They're saying put in negative 2. Put in negative 2. So I say, okay, put in negative 2, right in there in the X slot, right? Okay, and then work that out. Okay, so how do I do that? So what do you do with 1/3 to the negative 2? You got to flip it. Negative, first off, the negative part of the negative 2 says flip this thing, make it a 3/1 or 3. Then the power is positive. You with me? And it's 9 minus 27, which is negative 18. Is that okay? You can do it all at once. I might have confused you by doing it in stages. You can just look at that 1/3 and go, oh, negative 2, flip it, 3 squared, 9. You just jump right to the 9 if that's easier for you. Does that make sense? Again, negative powers flip, and then you do the power thing. Right? So the negative part flips it to be a regular 3, and the 2 power, 3 squared is 9. 9 minus 27, negative 18. Now, look what they say here. What is the point? I don't want you to be confused and waste hours of your life. On that, let me help you. Remember, a point just means xy, right? With parentheses, comma, xy, like point on a graph. So what's that? What do they mean correspond? Well, they just mean what x did you plug in, negative 2, and what answer did you get out? negative 18, that's your y. That's all they mean. Remember, with a function, whatever you plug in is your x, the answer you get out is y. They're just making sure you remember that. So what you plug in is x, right? Right there, they said plug in negative 2. What you get out, the answer is y. So the answer to the first part is negative 18. Then they say, what point is this? Negative 2, negative 18 is what they want from you. Let's go to B. Feel free to stop me if I'm going too quick. Let's go to B. H of x is 216. How do we do that? Let me write the h of x function here. 1/3 to the x minus 27. So there's the h of x function. They're saying h of x equals 216. So that means you stick the 216 in there for h of x, like that. You good to there? So I just plug the 216 in for the h of x side. Good. And now I need to solve that thing for x. How do you solve that thing for x? Can you do that? Let me give you a second. Rather than me just whipping it out, I think you'll get more out of it. Let's go ahead and solve for x there. So what is that? 232.43. 1/3 to the x. So 243 is 1/3 to the x. We good to there so far? And now, you know what I would do is I would just say, okay, look, I know I got to make that some kind of a negative thing to flip it, make it a regular 3, and then how many 3's to make 243? I would use my calculator. Just take 3 times 3 times 3, multiply a bunch of them. You'll find that it takes 5 of them to be 243 on that. Yeah.
Can we do logarithms?
Trey.
Yes.
Yeah. What's that?
Can we do logarithms?
Oh yeah, you can. If you already know that, you can. We will do that in the next section. But I can just do this in this way. So 5 3's multiplied together be 243. So then, do you see what x has to be? What power of x is needed then? Negative 5. Yes, everybody see that? Because the negative part of it will flip it and make it a 3, and then 5th power will make it that. Like that. Is that good? So x is negative 5, and we're done. With part, well, we're not quite done with part B, with the first part of part B. Is that okay on that? So you just look, when you see that 1/3 and the 243 and you're trying to solve, just think, okay, it's a 3 basically. How many 3's for 243? 5 of them. Choose your calculator. And then go, oh, but it's got to flip, so negative 5 on that. Okay, now, again, they're going to say, what point is that? Remember what you do when they say what point? I don't want to waste a bunch of your time on this, your homework. It's just the x, and then the y is the answer. What was the answer? Well, they gave me the answer in the beginning. The h of x, the function. Remember, function values are y values, so that's just the 216. So that's all they want when they say, what point is this? They mean what x, y, parenthesis, comma, put it together. That's what they want. So x is negative 5, and the point is negative 5, 216. Finally, part C. Part C says, find the 0 of h. Let me write the function again. So we have h of x equals 1/3 x minus 27. And they say, find the 0. We're doing part C up here. What does that mean, the 0 of h? What are they talking about? They mean literally just make h 0. Just plug in 0 and solve. That's what they mean. A 0 means the function or the y is 0. Remember, we found zeros on the number line, places it's x-intercepts. That's what it is. It's places the graph is a height of 0. So make the y, the function, 0. Okay, solve for x there. How do we solve for x? I would jump that 27 to the other side. Becomes a positive 27, right? Like that. Okay, so what power of x is needed there to make that into 27? Good. Does everybody see it's negative 3? Because, 3 3's, 3 times 3 times 3 is 27. You got to flip it. So that's why the negative part, huh? On that. Yeah. Karen. Right?
Well, Corinne.
Corinne. Oh, close. Okay, yeah, Corinne.
What if in part B, you have like this number that doesn't work with it, like nothing multiplies to it?
What number do you have, Corinne?
32.
What's the original function?
32 and then minus 64 or plus 64, so then you got positive 32.
Okay, yeah, but go ahead and give me the original h of x function that they have up here at the top for you on yours.
Oh yeah, it's 1 over 3x minus 64.
1 over 3 to the x minus 64, like that? Do I have it right? Okay, and then on part B, they're saying h of x equals what? 32?
Negative 32.
Negative 32, okay. Negative 32, so they're saying h of x is negative 32. So that would go in right there. So negative 32. Really? 32? Because you're right, that one wouldn't work. You sure? Maybe I'll come by and look at that one in a minute. I told no more history stories. All right. Even though I think history is interesting, your test will not be on history, and my job is to get you ready for your test. So, okay, so look at that. This is just plug-in. This is just plug-in is all it is. Don't waste much of your time on this. It just says x is years old, 3 years old. Just stick in an x, a 3, hit the buttons on your calculator. 17301, 0.92 to the 3, hit the buttons on the calculator. That's all there is to it. Part B, 9, put in a 9, hit the buttons on the calculator. Number 32 is exactly the same.